Okay, so before we go to the back, notice that on the front we were solving absolute value equations. Typically when we solve an equation we get a number or maybe 2 or 3 individual numbers. You all know that when you solve inequalities you get a lot of numbers and your answer might be something like x is greater than or equal to 4. And so there are a lot of numbers that satisfy that inequality that you were looking at. So our answers to these types of problems, I need you to recognize that our answers to these are going to look a lot different than the answers that we got to just an absolute value equation. So the best way to do this is probably, it's going to involve a graph. And what I'm going to do, I just want you to pretend for just a minute that you have an equation. Just for a minute. So let's take this greater than symbol. Let's take this greater than symbol and let's turn it into an equal sign. Just for a minute. And hopefully you watched the last video and you know how to do this. So there are your absolute value symbols. Let's look at the contents. I'm going to take out 2x minus 5. And I'm going to set the contents equal to the positive version of this number and the negative version of this number. Now, solve each equation. All right, we got x equals 4 and x equals 1. Well, that's not really true because keep in mind, my equation did not, my original inequality did not even include the equal to portion. It just said it had to be greater than that. So just because it said your absolute value had to be greater than 3, don't just say, oh, well, that just means that my answers have to be greater than 4 and greater than 1. Not necessarily true. Here's what I'd like you to do. Take the two numbers that we just got. Circle them on your graph. I'm going to circle -4, and I'm going to circle +1. And what do you think? Wait. My bad. I think I'm going to circle +1 and +4. My bad. Now tell me what you think. Do you think I should fill them in or not? I don't think so. Don't fill them in. My solution set is more than likely going to be either all of these numbers or these numbers between or these numbers over here. Let's find out which is the case. So come over here to this area to the left of the circle around 1. Pick a number. Pick a number that's easy to plug in. I like 0. Plug 0 into the original equation. Two times 0 is 0 minus 5. The absolute value of -5 is greater than 3. Is that true or not? The absolute value of -5 is just 5. If 5 is greater than 3? Yes, I like that. So what that means is I am going to shade all of the numbers to the left of 1. All right, pick a number in here. I think I'll pick 2. I'm going to test it and see if it works. and an absolute value of -1, I get +1. Is +1 greater than 3? I don't think so. So I'm not going to shade the middle part. Pick a number over here. I can pick 5 or 10 or anything I want to over there. -10 minus 5 is 5. Yes, that works. So come over here and shade all of this. Okay, almost finished. Now, I kind of didn't give you a place to do this on your paper, but write your solution set. Give me all of the numbers that we just colored green that work in my original inequality. So, starting with the left-hand side, I am going to go -infinity all the way to +1. Parentheses goes around -infinity. I am not including the 1. It's an open circle on 1. Do not include it. My math lab would want to see this. You know that I don't really care. And then my next set of parentheses, they're going to start at 4, not including 4, and they're going to go to infinity. And that is my solution set. I find it very easy to come up with a solution set if I already have a graph to look at. How did I get the graph? I found these two numbers right here, drew circles around them, and then plugged in a number to the left, in the middle, and to the right. Okay, let's do another one. Here are the absolute value bars. Let's work on getting the absolute value bars by themselves, and let's go ahead and pretend it's an equation just for a minute. So first thing we're going to do is we're going to subtract 5. Notice that I went ahead and changed it to an equation just to get those numbers that I can circle on my graph. I'm going to divide by -2. And now we're ready to take out the contents. So, I'm going to take out x plus 1. Don't change it. We are going to set it equal to the positive version of the number over here. We're going to set it equal to the negative version of the number over there. Solve them. 3 and -5. Circle them. Look back over here to determine whether or not you're going to color them in. We're not going to color them in. And then pick numbers to plug in. So I would pick like, you can pick anything. Maybe -10. Pick 0. Maybe pick +10. Turns out the only numbers that work are the numbers between. So all of these in here. Since 0 worked in your inequality, so will -1, -2, -3, -4, and 1 and 2, and all the decimals in between. Now, write the numbers that we just colored on our graph as a solution set in interval notation. Here we go. They're going to start at -5. Do not include it. Go all the way to 3. Do not include it. That's your solution set. What this says down here about ands and ors, I don't believe this is even in my math lab. So we're going to go with, for simplicity's sake, let's just go with changing it to equal sign just to make it easier. Find those two numbers, circle those two numbers on your graph, and then plug numbers in to the left, in the middle, and to the right, just to make everything easier on us. Okay, the last one's a word problem. When 4 times a number is subtracted from 5. Okay, so when you subtract something, you take it away. I'm subtracting 4 times a number from 5. The absolute value of the difference, the absolute value of what I just subtracted, it's called the difference, is at most 13. So it can lead up to 13, but it can't go over 13. That's what it should look like. Pretend for just a minute that it's an equation. Take out the contents. This was a positive 13. I set this equal to the positive version and the negative version. Solve each piece. Circle -2. Circle positive 4.5. Color them in. Pick a number over here. Pick a number in the middle. Pick a number over here. And what you'll find out is all of these numbers work. So I could then say that my solution set starts at -2, goes all the way to 4.5, and we want to include them. There we go. All right, well, hopefully that gets you through your notes for Tuesday, and hopefully you'll be able to zoom through your My Math Lab homework.